Okay, this lesson is on applications of linear equations. Before we actually do some applications, we need to cover a few phrases that we see. We have to know how to translate these words into expressions. The first one we have here is 6 more than a number. 6 more than a number actually means 6 plus a number. We'll use x for the number that we don't know. 6 plus a number. The sum of 5 and a number, same thing. The sum of 5 and a number means 5 plus some number x. A number increased by 2. A number is our x. Increased by 2 means you add 2 to it. So that's x plus 2. The sum of two numbers. Since we don't know the two numbers, we'll call one x and the other one y. So x plus y is the sum of two numbers. So all of these phrases represent some sort of addition for us. Next one, 12 minus a number would be 12 minus x. Do not get that confused with 12 less than a number. 12 less than a number means the 12 is in the back, so it's actually x minus 12. I have a number and it's 12 less, so I go x minus 12. Students sometimes get these mixed up, so be very careful. The difference between two numbers. The difference between two numbers is x minus y. A number subtracted from 10. So I'm taking 10 and I'm subtracting a number from the 10, so it should be 10 minus x. So my number is subtracted from the 10. A number decreased by 12. It's my number x, and it's being decreased by 12, so minus 12. So all of these represent some sort of subtraction. Excuse me. Our next one is 16 times a number. That'd be 16 times x. 2/3 of a number would be 2/3 times x. Twice a number is twice x, 2x. And the product of two numbers, the product means multiplication, so that'd be xy, or x times y. So all of these represent some sort of multiplication. And the quotient, or ratio of two numbers, quotient means division, so that would be x over y. Quotient or fraction, division, same thing. Okay, so those are some of the phrases that we're going to come across here. We now know how to put them or write them as a mathematical expression. Now to solve an application problem, we first read the problem, obviously. We then assign a variable that we need. We write an equation for the problem, then solve the equation, and then we write down the answer, and then of course check the answer. Make sure that it makes sense. Here's our first application. The length of a rectangle is 1 centimeter more than twice the width. The perimeter of the rectangle is 110. Find the length and the width of the rectangle. Sometimes it helps to draw a picture, not always, but there's my rectangle. Now it says that the length is 1 centimeter more than twice the width. So I'm going to assign my variables. I'm going to let w equal the width of the rectangle. And it says up here that the length right here is usually means an equal sign, 1 centimeter more, so we know that means 1 plus, twice the width, that would be 2w. So the length is equal to 1 plus 2w. I have assigned my variables. And so the width over here, this would be w, and the length is 1 plus 2w. Now we know that the perimeter of the rectangle is 110 centimeters, so the perimeter formula for a rectangle is twice length plus twice width. And that's the same as adding up all the sides. You get w plus w plus this again. Add it all up, you get the perimeter. Now the perimeter, it says, is 110, and so that's twice L plus twice W. But the length, as we have found here, put it right in there, is 1 plus 2w. And so this is the equation which I need to solve. So let's solve this for w. I first have to distribute that 2, so that'll be a 2 plus 4w plus 2w. That'll be 110 equals 2 plus 6w. Move the 2 or subtract 2 from both sides, and we get 100. Let me put that up here. I'm running out of room. We got 108 equals 6w, and then we divide, and 108 divided by 6 is 18. So I found the width. The width is 18. Now the question is find the length and the width, so we also need the length. So if I go right up here, I've got that the width is 18. So I should do a different color here. 18. And now I can get the length. The length will be 1 plus twice 18, which is 37. And so I'm going to write my answer down here. Normally I wouldn't squeeze it in here, but I'm short in room here. The length is 37 centimeters, and the width is 18 centimeters. And we could check that result by adding up 18, 18, 37, and 37, and all four of those numbers should add up to the perimeter 110. And so we have our result. All right, next one. In 2002, Randy Johnson and Pedro Martinez had a combined total of 573 strikeouts. Johnson had 95 more strikeouts than Martinez. How many strikeouts did each pitcher have? Let's define our variables. It says that Johnson had 95 more strikeouts than Martinez. So if we let x equal, let me change the color here. If we let x equal the number of strikeouts for Martinez, then what would be the number of strikeouts for Johnson? Well, the problem here says Johnson had 95 more strikeouts than Martinez, so that would be 95 plus the x. If x is Martinez strikeouts, then Johnson has 95 plus that. So I've defined my variables. Now I have to come up with an equation. It says that the number of strikeouts for Martinez, let me just, I'm going to abbreviate here, N for Martinez, plus the number of strikeouts for Johnson is supposed to add up to, or total, 573. So the equation I need is x plus 95 plus x equals 573. That's the equation I need to solve. This is 2x plus 95 equals 573. Subtract 95 from both sides. 2x equals, use my calculator here, 478. Divide that by 2, and we get x equals 239. Okay, so if x is 239, let me take that, go right up here. That's this. 239 is the number of strikeouts for Martinez. So for Johnson, that would be 95 plus 239. 95 plus 239 totals 334. So this number is 334. And so my answer, let's write out our answer here. For Martinez, 239 strikeouts. For Johnson, 334. And how would we check? Well, if we take 239, this is the check here, plus 334, does that add up to 573, the total? And it does. So we have our correct answer. All right, next one. In 2002, there were 301 area codes in the U.S. This was an increase of 250% over the number of area codes in 1947. How many area codes were there, lowercase w, how many area codes were there in 1947? So that's what we're trying to find. We'll let x equal that. X is the number of area codes in 1947. Now there's 301. So the increase is, it says that it increased 250%. 250% of the number of area codes in 1947. So if I want to increase a number by percentage, I have to take that number x and I multiply it by that percentage as a decimal. 250% as a decimal is, I'll put it on the side here, 250%, you take the decimal point and you move it 2 over. So this is actually 2.5 as a decimal. The increase is 2.5x. In other words, an increase of 250% means you take the original amount x and you multiply it by 2.5 times itself. So the number of area codes in 1947 plus the increase gives you the total number of area codes in 2002. And so the equation should be, you take the number of area codes in 1947, add on the increase, which is 2.5x, that means 250% increase, and that should total 301. That's the equation I need to solve. Now let's combine our like terms. That's really a 1x plus 2.5x is 3.5x equals 301. Let me fix that. Divide by 3.5, and we get x equals 86. And so as my answer, I have 86 area codes in 1947. 86 area codes. Here's our check. Put it right here on the side. And we'll use red for this. Here's how we check our result. So we take the 86, which is how many area codes we have in 1947. We add on 250% of that. So 250% of 86 is 86 times 2.5. And if we use our calculator and multiply that together, we will get 301, and so it does work out. Next one. A number increased by 15% is 287.5. Find the number. So let's let x equal the number. So what's the increase? We're increasing the number by 15%, so that means we're taking it and we're multiplying it by 0.15. That's the 15% increase. So the equation is, we take the number plus the increase, and we get the 287.5. The number was x. The 15% increase is 0.15x. Don't forget the x here. A common mistake is for somebody to do that. That's not a 15% increase. That's just adding 0.15 to a number. So we want 15% of x, which is right there. That's the increase as a percentage. And that should equal 287.5. So we solve that for x. We combine our like terms. That's 1.15x equal 287.5. 287.5 divided by 1.15 is 250. And so my number that we're looking for is 250. Here's our check. Put it right here. If we take 250 and we add on 15% of 250, which looks like this, that's 15% of 250. Type that in your calculator and you're going to get 287.5. And so it works. All right, next one. Michelle was paid $162 for the week after 10% deductions for taxes. How much did she make before the deductions? So we'll let x equal the pay before deductions. So let's find the deductions. The deductions were 10%. So we're going to take away 10% of her pay. 10% of x is 0.10x. The 10% is the decimals of 0.10. So we take her pay before deductions, subtract the deductions, and we should get the amount that she actually got for the week, which was 162. So the equation we need to solve is x, take away 10% of x, equals 162. That's what we're going to solve. Let's combine our like terms. I have 1x minus 0.10x, which, let me put it up here, is 0.9x. Divide by 0.9, 162 over 0.9, like that. And let's see what we get. 162 divided by 0.9 is $180. And so our answer here is she earned $180 before deductions. Okay, and that is part one on solving applications of linear equations.